Any questions from yesterday? Okay. A new topic is logarithms. And first, we'll be looking at how to convert index form into logarithmic form and back again. For example, we have why isn't it working? Just a second. Okay. For example, we have x raised to power y is equals to p. This is index form. So when you convert it into logarithmic form, this goes underneath this. It is y is equals to log of p to base x. A raised to power b is equals to c, so it will be b is equals to log of c to base a. Power actually comes down and this figure goes on the other side. Power comes down and this figure goes on the other side. It could be written in either way. For example, w is equals to q raised to the power p. So remember, whatever the power is, that will come down and the number in the base goes on the other side. So this is log of w to base q. So if you have a logarithmic form, the reverse is true for that. Y is equals to log of p to base x. So whatever is in the base goes on the other side and lifts that up, and this becomes this. Reverse of that. So logarithmic form to index form and index form to logarithmic. This is index to logarithmic form. And this is logarithmic form to index form. For example, we have 10 raised to the power x is equals to 0.9. So value of x would be, we apply logarithms. This is x is equals to log 0.9 to base 10. So you can punch this number in your calculators. Yeah, 0.9. minus 0.046. That's x. So logarithms. The inverse of exponential functions are called logarithms, relationship which is expressed as logarithms, and write each statement as logarithm. Now this is 3 raised to power 2 is equals to 9. 3 raised to power 2 is equals to 9. So power comes down, the number goes on the other side. This is log of 9 to base 3. So this is in logarithmic form. Let's study few rules and then we'll continue with the questions. You have to understand log a b. A is positive, b is positive. Both of them are always positive and b cannot be 1. Why it cannot be 1 is because we can write this as log of a divided by log of b. When there's nothing in the base, it is understood that it is 10. Why it cannot be 1 is because log of 1 is equal to 0. So if anything, at the... Yes, Mohammed? Different calculators work in a different way. For example, I have this calculator which shows me this button, log box and box. If you have a different one which doesn't show this, so you will be writing it like this, log of this, and then use a division sign or brackets and divided by log of this. Both are true. Both logs. Like for example, log 3 to base 4 could be written as log of 3 to base divided by log of 4, and not this. Okay. So we were discussing why it cannot be 1, because log of 1 is actually 0. So when 0 comes into the base, that becomes a math error, undefined. So first rule, every value is positive which is inserted in log, and base cannot be 1. Second, there is a power rule. For example, we have any number 2 raised to power x is equals to y. So when I apply log on both sides, so I'm applying log on both sides, what happens, this power actually comes down and multiplies with it. So this is x log 2 is equals to log y. This is known as power law. So now if I make x the subject, I can write this as log y to base divided by log 2, and this could also be written as log y to base 2. For example, if you are asked to solve without using a calculator, let's say we have 2 raised to power x is equals to 16. So I can apply log on both sides, and this will become log 2 raised to power x is equals to log 16. Now I'm using power rule and bringing this x down. So this is x log 2 is equals to log of 16. So x is equals to log of 16 divided by log of 2. Now remember, the question said that solve it without using calculator. But you will be having calculator with you at all times. So that only means you have to show each and every step. Now x is equals to log. May I write this 16 as 2 raised to power 4? Now this 4 can actually come out by power law. So we can write this is equals to 4 into log of 2 divided by log of 2. So you get rid of this and your answer is 4. Yes. Now we're just discussing it. It would be simpler than that. For example, we just discussed this question. This could have been one step, 2 raised to power x is equal to 2 raised to power 4, right? Using indices. The only purpose to use this simple value was to avoid use of calculator. Your mind should accept that yes, x is equals to 4, no matter how you do it. In case of logs, yes, Mohammed. Can you just send me the picture? Yeah, WhatsApp, how it looks like. Meanwhile, I'll copy few questions. Now, first we were converting an index to logarithmic. Now this is logarithmic form and we have to convert it into index form. So I'm taking this 3 on the other hand side. This becomes 81 is equal to 3 raised to power 4, which is 81 is equals to 81. So this is the index form. Now you can take this 2 on the other side. You're left with 1 by 8 is equals to 2 raised to power minus 3. Both are equal. If you have to show left hand side equal to right hand side, you can solve it further, or else requirement of question was this only one step from logarithmic to index form. Okay, I'm just looking at that picture of the box. Yeah, that's it. You just have to fill in the values. This appears like this. These are the boxes. You can fill in the values log 4 to base 3. This is how you fill them. Okay, this was index to log, log to index. This exercise is using only these two properties. There are more to it. Let's take them step by step. It says without using calculator, find the value of log 8 to base 2. These questions are interesting. So this is log 8 to base 2. May I write it as 2 cube to base 2? 8 could be written as 2 cube. Next step is using power law. I am bringing this 3 on the outer side. So I'm writing 3 log 2 to base 2. And if you can see, this log 2 to base 2 could be written as log 2 divided by log 2. We are not writing it, we're just considering it, and our final answer is 1. Or we can say log b to base b is actually equal to 1. Question 3b part. It says log of 25 to base 5. So I'm writing log 5 squared to base 5, bringing this 2 outside, making it 2 log 5 to base 5. So my final answer is 2. So log 25 to base 5 actually means 2. Look at this f part. Log of square root 10 to base 10. So this is log of 10 raised to the power 1 by 2 to base 10. I'm bringing this 1 by 2 outside. So this is 1 by 2 log of 10 to base 10. When you have both of the numbers same, that is 1. So your final answer is 1 by 2. Now there's one more property. For example, you have log 5 to base 25. We just did log 25 to base 5, which was 5 square to base 5, and bringing this 2 outside made it log 5 to base 5, and the answer final was 2. In this case, compare these two. We can write log 5 to base 5 squared. Now this 2, when it comes out, this becomes the reciprocal. It is 1 by 2 into log of 5 to base 5. So this thing in bracket becomes 1, and your answer is 1 by 2. In general form, if I write log of b a par x, next step would be x log b a. And if we write log of x y and par is p, this would be 1 by p log x y. Are you getting it? When you bring power outside, when it is above this number, this becomes only x. When it is in the base, it becomes 1 over that number, reciprocal of that. If I have this log 8 2, this will become log 2 cube to base 2. Now this 3 is going to come out. This is log 2 to base 2. This 3 comes out as it is, and our final answer is 3. But if we had log 2 to base 16, log 2, this is 2 raised to power 4, 16 is 2 raised to power 4. Now this 4 is coming out and becoming reciprocal because it was in the base. This 2 would make it 1, and your final answer is 1 by 4. Okay, we did few questions from 3. Now see question number 4. Without using calculator, find the values of x. So question 4, look at this a part. This is log of x to base 5 is equals to 4. I'm changing it into index form. This 5 goes on the other side, x is equals to 5 raised to power 4. So you just use your calculator. 5 raised to power 4 is 625. Value of x is 625. Look at question number 4, E part. It says log of 4x plus 1 to base 3 is equals to 4. So changing it into index form makes it 4x plus 1 is equals to 3 raised to power 4, and 3 raised to power 4 is 81. So 4x plus 1 is equals to 81, 4x is equals to 81 minus 1, 4x equals 80, and x is equals to 80 by 4, that is 20. Now use your calculator. We're just skipping this question number 5. You just have to punch it in your calculator and get those values. Let's do one single question, this P part, just to see if we all are using it correctly. Please solve and share your answer. This is it. Punch it in your calculator. The question is log of 33 to base 5, and let me know if your answer is 2.1. That's it. What about Mahad and Yahya? Okay. Question number 6. Without using a calculator, justify why the value of log 52 to base 2 must be between 5 and 6. Okay. So this is log of 50 to base 2. And why it should be between 5 and 6. Now, if I'm not using the calculator, I know that we've just discussed log x to base x is basically 1. So it should have been something close to that, close to 2. And it is between 5 and 6. So what can I do with this 50? If I try to change it, I can say 7 square is actually 49, which is close to 50. So I'm trying different numbers. Yes, Mohammed. Yes, this was the first guess. We'll be doing that, but we know that 50 isn't there anywhere. For example, 2 power 1 is 2, 2 power 2 is 4, 8, 16, 32, and then 64. So this is 2 power 3, 2 power 4, 2 power 5, 2 power 6. So, yes. So if it would have been 32, we can say this is log 2, 2 raised to power 5, and 5 log 2 to base 2. This would have been 5. And if it would have been 64, so log of 64 to base 2 makes it log of 2 power 6 base 2, and taking this 6 out, so log of 2 to base 2. So 32 makes it 5, and 64 makes it 6. So definitely 50 would be in between 5 and 6. B part is use of calculator. So that's easy. Find the values of these. Log 2 to base 2 is 1. 3 to base 3 is 1. Log 17 to base 17 is again 1. Okay, find the values of log 1 to base 2. Log of 1 to base 2. We know that log 1 is actually 0. So 0 divided by anything is 0. Okay, now it says explain why log 1 to base a has the same value for whatever the value of a is. So actually it is log 1 divided by log a, you keep on changing the value of a, nothing happens because numerator is 0. So whatever the value of a is, the final answer is 0. Now, now yes, okay. From logarithms, okay. Without using calculator, find the value of this. So this is log of 81 to base x is equals to 2. Log of question 4b is log of 81 to base x is equals to 2. Rules are same. I'm changing it into index form, taking this x on the other side. So this is 81 is equals to x raised to the power 2. Now what should I do to have the base or power same? So I'm thinking of 9 square is equals to x square. Therefore, x is equals to 9. Okay. Index to log, log to index. A few more rules, and what are they? Now this is very simple. It is from logarithmic to index form, first thing. Second thing is when you basically multiply the numbers in logs, they add up. For example, if I write log of xy to base a, if I split them, this will become log of x to base a plus log of y to base a. So when you are adding logs, the reverse is multiplication. For example, if you have log of x plus log of y plus log of h, when you are adding them, this will become log of x multiplied by y multiplied by h. When they are adding up, they multiply when you write them as a single log. And what happens when you divide them or subtract them? When you subtract them, they go for division. Log of x plus log of y minus log of q. Now what happens when you write them as a single log? Where they are added up, they multiply. Where there is a subtraction sign, they divide. So this was the next rule. It won't be in this case. Like you can go from here wx over y. This reverse is possible. W plus log of x minus log of y. The one in denominator comes with a negative sign. The one in numerator comes with the positive sign. Now see these laws. This first one, you see the addition sign, so they become xy, multiply. You see this negative sign in the second line, they divide. You see this k, this is the power law, we discussed it earlier. So multiplicative law, division law, and power law. Then we discussed this thing also. Values in logs are positive. First thing, the value in the base cannot be equal to 1 because log 1 is 0. For example, write this as single log. You see this log 6 to base 3, log 7 to base 3. If we combine them, I can say this is log of plus. There is a plus sign. So 6, 7 times is 42 to base 3. If you have to show working, for this B part, we'll be writing log of 15 divided by 3 to base 2. So next step would be log of 5 to base 2. Getting it? Look at this C part. So C part says 2 log of 3 to base 5 plus 3 log of 2 to base 5. The base needs to be same in order to write them as single log. Now I'm taking this 2 inside and writing log of 3 square to base 5 or directly 9. I'm taking this 3 inside and this time I'm directly writing 3 raised 2 raised to power 3 is 8 to base 5. So this is log of 9 to base 5 plus log of 8 to base 5. So when they are added, they're actually multiplied with each other. So this is log of 9 into 8 to base 5, making it log of 72 to base 5. So this statement, yes, could be written as this. We'll do something about them. That is, for example, okay, you have log of 2 to base 3 plus log of, let's say, 4 to base 5. Now this law is actually known as change of base law. So you can write log of 2 divided by log of 3 plus log of 4 divided by log of 5. When there's nothing in the base, it is understood that this is 10. So now I can write them as single log. I'll skip this for now. This would get complicated. Taking it step by step. But this is how you do it. Change of base law. This is known as change of base. When it is not same. One small example to avoid any confusion. For example, you have log of a to base b, but on the other side you have log of b to base c. So if I take reciprocal of this first thing, this will become 1 over log of b to base a. They're actually switched. I should have taken reciprocal of the second item. So this is log of a to base b plus 1 over log of c to base b. They get switched when you take reciprocal. So now the base is b and the base is b. Next step would be taking the LCM. Coming back to the exercise. Write in terms of logs. Now this is reverse of what we were doing. They are already multiplied. So I can say this is log of first is x square plus log of second is y plus log of third is z cube, and base was a for every one of them. Further extension of this could be bringing this power outside, making it 2 log x to base a plus log y to base a plus 3 log z to base a. When it is multiplied, you add them. When it is divided, you subtract them. Yeah, both are acceptable. Question statement would dictate that. For example, they may tell you that leave your answer in this form. For example, this question could have said p log x q something. So we'll know that we have to bring the power outside. Now let's see this. Write as single logarithms. This is again same. Write as single logarithm. Again same, but let me do this question 2D. Question 2 part D. It says log of 25 to base 8 plus log of 10 to base 8 minus 3 log of 5 to base 8. So writing them as single log. Log of 25 to base 8 plus log of 10 to base 8, and taking this 3 inside, 5 cube is 125, so minus log of 125 to base 8. Next step, where they are added, you multiply. So log of 25 multiplied by 10 divided by 125. Simplifying it, so this becomes log of 2 to base 8. Mahad, question was to write as single log. This is done. If the question would have been simplify, there's more we can do. So log 2, and this 8 could be written as 2 cube. So when we take this 3 outside, this becomes a reciprocal. Log 2 to base 2, and final answer is 1. So if we are required to write a single log, this is our answer. If it tells you to simplify, our answer is 1 by 3. Any issues? Yeah, you getting it? Okay, question number 3. Now see, question 3 is telling you that write in terms of this thing. So log of x cube y4 z to base a. We can see all of them are actually multiplied. So when you take reverse of that, there will be addition sign. So log of x cube to base a plus log of y power 4 to base a plus log of z to base a. One more step to get them in form of log x, log y, log z. So this is 3 log x to base a, 4 log y to base a, log of z to base a. Is it clear, Mahad? Question will always dictate what they're expecting. Sorry, which one? 3b, okay. Question 3b is log of x power 5 divided by y square to base a. So now I can see divide, it would be negative. This is log of x 5 to base a minus log of y square to base a. First step. Second step, bring the powers outside. 5 log x to base a, this is known as power law. Log of y to base a. This is done. Let's try this D part also. This is log of x divided by square root y and z to base a. Now we have two things in division, so there will be two negative signs. Log of x to base a minus log of square root y to base a minus log of z to base a. Next step, log of x to base a. We know this square root is 1 by 2 minus 1 by 2 log of y to base a minus log of z to base a. As far as the question is concerned, that if do we have to show each and every working, the answer is no. You may do it directly, but do it carefully, avoiding mistakes. As we solve the following equations. Now we are doing for the unknowns. Question number 4a says log of 3 to base 2 plus log of x to base 2 is equals to 2. You may have different approach. Now I'm converting it into single log. So this becomes log. There's an addition sign, so these two multiply. This becomes 3x to base 2 is equals to 2. Now I'm going for log to index. This 2 goes on other side, becomes 2 raised to power 2. 3x is equals to 4 and x is equals to 4 by 3. Got it? Let's see this 4D. Base stays in the base. The number on opposite side becomes the power. This 2 becomes the power and this base is at the base. For example, this was log of x, y is equal to z. This becomes x is equals to y power z. Base is not going in the power. 4D is 2 log of x plus 1 to base 9 is equals to 2 log of 2x minus 3 to base 9 plus 1. Now there are two ways we can do it. One is we bring this to left hand side because both are log and log, and the other thing is I convert this one into logarithmic form. So we haven't did that yet, so I'll convert that first. So you see this is also possible. Is equals to log of 2x minus 3 raised to power 2 to base 9. You see this was the reverse of power law. And may I write this 1 as log of 9 to base 9? So you see, when you have log of x to base x, that is 1. So we know when both are same, answer is 1. So you can make a reverse of that. And why I chose 9? Because we had 9 in the base. This one could be written as log of 5 to base 5, but this 5 won't be helpful. So I used log of 9 to base 9. Now on left hand side it is log of x plus 1 squared to base 9. On right hand side you see this positive sign, it changes into multiplication. So this is log of 9 into 2x minus 3 whole squared to base 9. Now if you can compare left hand side and right hand side, both of these are same. We call it applying anti-log. Students confuse them with cancelling with each other. This is basically applying anti-log. Or you can say left hand side is equal to right hand side. So these two expressions are equal. So it says x plus 1 whole squared is equal to 9 into 2x minus 3 whole squared. So this is a square plus 2ab plus b square is equals to 9 into a square minus 2ab plus b square. X square plus 2x plus 1 is equal to 9. 4 times 36x square. 9 into 12 is 108. X plus 81. Now we rearrange. 36 minus 1 is 35x square. Negative 108 and 2 is negative 110x. 81 minus 1 is plus 80 is equals to 0. Before we continue, I'm trying the same question with a different method, and we'll compare these two equations. For example, this was the very question. 2 log of x plus 1 to base 9 is equal to 2 log of 2x minus 3 to base 9 plus 1. This was the question. Now I'm simplifying it and we'll compare if we get the same equation. Now this becomes log of x plus 1 whole square to base 9, and I'm bringing this to left hand side along with simplifying it. So this is log of 2x minus 3 whole square to base 9 is equal to 1. Any confusion till now? Now we see this is 9 in the base. So I can convert them into single log, and I'm noticing this negative sign, so I'll have to divide. So we'll write 9x plus 1 whole square divided by 2x minus 3 whole square to base 9 is equal to 1. Is it okay? Now you can apply logarithm to index form. This 9 goes on the other side and it becomes x plus 1 whole square divided by 2x minus 3 whole square is equal to 9 raised to power 1. Now we simplify. This becomes a square plus 2ab plus b square in the numerator, and this thing expands and goes on the other side, becomes 9 into a square minus 2ab plus b square. X square plus 2x plus 1 is equal to 9. 4 times 36x square. 9 into 12 is minus 108x. 9 into 9 is 81. Now take this x square on the other side, it becomes 35x square. We take this 2x on the other side, this becomes minus 110x. Take this 1 on the other side, this becomes 80 is equals to 0. Now compare these two. You see, whatever path you take, they are same. Now for the value of x, I'm going for quadratic formula. Minus b plus minus square root b square minus 4ac over 2a. So this is minus 110 plus minus square root b square minus 4 into a into c divided by 2a, and use of calculator. Minus b plus square root b square minus 4 into a into c over 2a, and something happened. Can you please share the answer? Use your calculator. I'm getting one answer as 2 and second as 8 by 7. Minus 1 by 0 squared. Minus 110, yes. A, B, and C. So I'm getting 2 and 8 by 7. Yeah, I'm missing your voice. Okay. Can Mahad, are you getting these answers? 2 and 8 by 7? I think this is the answer. I just wanted to double check. I'll try again. This is 110 squared. And if you're putting a negative sign, you should use brackets. That's 2 and 8 by 7. So this was about exponentials and logarithms. 2 and 8 by 7. Yes, that's it. What else we'll be looking at? Okay, solving equations, working with natural log. 1 to 2 concepts are there, and then we'll be done with this chapter. Inshallah, we'll cover them tomorrow. Natural logs.